Have you ever wished you could be somewhere in a blink of an eye? Imagine the thrill, the sheer exhilaration of vanishing from one place and reappearing in another, without the tedious necessity of physical travel. This is the captivating concept of teleportation, a staple of science fiction that has captivated our collective imagination for generations. Think about it. How many times have we seen characters in Star Trek simply beam from their spaceship to a planet below, bypassing the constraints of time and space? Or how about the instant travel portals in the Harry Potter series? These are just classic examples of teleportation, weaving its magic in popular culture, illustrating its widespread appeal. The idea of teleportation, of instantaneously moving from one place to another, is a concept that continues to fascinate us. Now, what if this fantasy could become reality? What if teleportation isn't just confined to the realms of science fiction? So what exactly is teleportation? Let's start with the basics. Teleportation, in its purest form, is the process of moving objects or individuals from one place to another instantaneously. But it's not just about moving, it's about breaking down and reassembling. Imagine you are an intricate Lego structure. Teleportation would involve disassembling you, brick by brick, then sending those bricks to a new location and finally reassembling you, perfectly intact. But instead of Lego bricks, we're talking about atoms, the building blocks of matter. The first step in teleportation is dematerialization. This is where the object or person to be teleported is broken down into their most basic particles. It's like taking a picture of every single atom in your body, capturing not just what atoms are there, but also their precise arrangement. Next comes the transmission phase. This is where those particles and the information about their arrangement are sent to the target location. It's not too dissimilar to sending an email. You type out your message, hit send, and it arrives in someone else's inbox almost instantly. But instead of words and sentences, we're sending atoms and the information about how they're arranged. The final step is reassembly. This is where the particles are put back together in their original form at the target location. It's like 3D printing, but on an atomic scale. Using the transmitted information, the atoms are arranged in the exact order to recreate the original object or person. But don't worry, while this might sound like a scary process, in theory you wouldn't feel a thing. One moment you're here, the next moment you're there, without any sensation of the journey in between. Sounds like something straight out of a sci-fi movie, doesn't it? But how far are we from making this a reality? Quantum physics might have an answer to our teleportation dreams. Quantum teleportation. It sounds like something straight out of a science fiction novel, doesn't it? But it's not. It's a real concept in the world of quantum physics. Now, before we get too excited, let's clarify something. When we talk about teleportation in the quantum world, we're not referring to the physical movement of matter from one place to another as portrayed in movies. Instead, we're talking about the transfer of quantum states between particles. Picture this. You're holding two particles. Let's call them Alice and Bob. Alice and Bob are entangled, a peculiar quantum phenomenon that links their states no matter the distance between them. Alice is in New York and Bob is in London. If Alice changes her state, Bob instantly changes his state to match hers. This instantaneous change is what we refer to as quantum teleportation. But how is this possible? Well, it all boils down to the principles of quantum mechanics. According to these principles, a particle can exist in multiple states simultaneously until it's observed. This concept, known as superposition, coupled with entanglement, makes quantum teleportation possible. Now here's the really exciting part. Scientists have actually managed to achieve quantum teleportation. In a groundbreaking experiment, a team of researchers successfully teleported information about the quantum state of a photon, a light particle, across a distance of 6 kilometers. However, it's crucial to remember that quantum teleportation is still in its infancy. We're not yet at a point where we can teleport large objects or humans, but the successful teleportation of a photon's quantum state is a significant milestone. It demonstrates that the concept isn't just theoretical, it's real. So, while it's not exactly what we see in science fiction, quantum teleportation is a real phenomenon that scientists have already achieved. Scene script. Teleporting a human being is a whole different ballgame. In our previous scenes, we've explored the fascinating concept of teleportation, its understanding, and its existing application in the quantum world. Now let's unravel the challenges of teleporting a complex entity like a human being. Imagine for a moment the intricacies of the human body. It's not just a collection of cells, but a bustling metropolis of over 37 trillion cells, each with its own function and purpose. There are approximately 100,000 miles of blood vessels, 25,000 genes, and a brain that holds as many neurons as there are stars in our Milky Way galaxy. It's an awe-inspiring, complex system. And that's before we even consider the soul, consciousness, or individuality. Now imagine trying to precisely replicate every single one of these components at a different location. The task is not only to move these components, but to reassemble them in the exact same order, down to the last atom. A single misstep could be catastrophic. The sheer volume of information to be transferred is staggering. To put it into perspective, if the information in the human body were to be written down, it would fill the Grand Canyon 5 times over. And that's just the physical part. What about our memories, thoughts, and feelings? How do we ensure they make the journey intact? Moreover, there are ethical and philosophical challenges. Is the teleported person the same as the original? What happens to the original? Does it die? And if so, is teleportation just a fancy form of cloning? There are also technical challenges to consider. We would need a way to scan the body at the atomic level, a method to transmit this staggering amount of information, and a mechanism to reconstruct the body at the destination. All these technologies are currently beyond our reach. As of now, teleporting humans remains a distant dream, but who knows what the future holds? So where does this leave us in our quest for teleportation? Well, even though teleportation, as depicted in popular culture, still belongs to the realm of science fiction, the quantum form of teleportation holds some exciting possibilities. Imagine a future where quantum teleportation is used to create ultra-fast, unhackable communication networks. Or consider a world where quantum teleportation becomes a key tool for advanced computing, opening up new dimensions of data processing and artificial intelligence. The potential implications are vast, but they all hinge on further advancements in technology and our understanding of quantum physics. As science pushes these boundaries, we may begin to see teleportation move from the realm of quantum particles to something more tangible. The journey is challenging, the vision audacious, but the rewards could be immeasurable. Teleportation may not be here yet, but it's closer than you might think. And who knows, in the not-too-distant future, you could be teleporting your way to work.